Okay, good evening, ladies and gentlemen. Good morning already. It's February, no, no, February, October 10 already. Okay, what I will be discussing tonight will be on how to charge this chargeable battery here, a lithium-ion battery. So, the safe way on how to charge this one is actually to bring out the terminals, okay, and try to make the other terminal shorter than the other one. Why it's shorter? It's shorter such that when you try to connect the positive terminal here and the negative terminal here, they will be far from each other, okay, and there is no chance of them shorting out each other because if the positive terminal and the negative terminal of the charging cable should be connecting to each other unintentionally, okay, that's a short circuit and it's very dangerous. You might be killing your, what they call this, or destroying your power supply, and you don't want that to do it. So to avoid shorting out your power supply, when you are charging a battery, make sure that the negative terminal is far away from the positive terminal. Uh, I will be using this charger here to charge the battery. The voltage requirement of this one to for it to charge is actually 5 volts. That's why I set the voltage of this one now to 5 volts, 4.92 or 5 volts. Okay? So instead of using this one here to charge this one, okay, because the output voltage, this is actually a battery charger for cell phones, okay, and we could use this one to charge this battery here, but since I know how to bring out a power supply in which the voltage output, I could make that to the exact value I needed. I will now be charging this one using my variable power supply. Okay, and I set it to 5 volts or 4.92. Okay, same as the power output or voltage of this one. Because if you try to bring out the cable here and you try to measure the voltage across it, it should be 5 volts. Because the voltage of this one, after it is fully charged, is 3.7. And for it to be charged, of course, the charging voltage should be greater than 3.7. And for a USB something like this, it is actually 5 volts. So by using my regulated power supply, it seems I am using this one. Only that I am using my assembled power supply. So to charge this one, okay, I will be connecting an ammeter in series with the power supply, the red terminal. Okay, I connected it already. Okay, and it will pass through the ammeter. Okay, and for the correct charging process, the red terminal of the power supply should be connected here, and the black terminal of the power supply should be connected here. Okay, so I will now be connecting the end of the ammeter to the positive terminal. Okay, and the negative terminal of the battery, I will now be connecting that to the uh, negative terminal of the power supply. Okay, and I set the multitester to measure DC current. Okay, right now the charging current emanates from 0.35, it's going down, then it will stabilize to a certain value. We are waiting for the stabilizing value. The stabilized charging current now is 0.183 amperes, or in terms of milliampere, that's 183 milliampere. So while we are charging this one, the charging current is 180 milliamperes by using my power supply, in which the voltage output was set to 5 volts. I don't want to charge this one with the voltage greater than 5 volts because supposed to be because this might burst. What do you call this? The charging voltage is too high. So I just follow the voltage requirement of this one because the output voltage of this one is 5 volts. And since I'm using my assembled power supply, I set that to 5 volts. Okay, so right now the charging current it's going down because supposed to be as the battery charges, actually the charging current will start from that initial value. After it is fully charged, of course, this charging current of 164 milliamperes will drop to zero. If it drops to zero, meaning to say the battery is not anymore what you call this needing current for it to be charged because it is already fully charged. So the significance of this current here, if it is already zero, meaning the battery is already fully charged. Okay? And I want to show you that the terminals of the battery, the minus and the plus, is actually far from each other. Even though we do it like this, there is no way the plus terminal of the power supply will be short-circuited to the positive terminal of the power supply. So the significance of the shorter and the longer one is actually to avoid shorting the terminals of the power supply which you are using to charge a battery. Okay? They are far away from each other, right? Because this is higher, this is lower. Okay? So they will not be shorting out each other. That is actually a very good practice if you are charging battery. It's just like if you are charging your car battery, avoid touching the plus terminal and negative terminal because if you try to connect the plus and minus terminal while you are charging your car battery, okay, there might be an explosion because the current will be too high for that one. In this one here, it's not too high, but at least we must have to avoid shorting the negative terminal of the power supply from the positive terminal of the power supply. They are far away from each other, right? So this is a good practice while you are charging your battery. Right now, the current, charging current drops to 159 milliamperes. A while ago, it was 164. Like what I said, when this current goes to zero, the significance of that is that the battery is already fully charged. Okay? Good morning from Los Angeles. This is Professor David J. De Los Reyes.